terminal and let's begin coding. Yes, here is our regular folder, and as you can see it, we have our files and our files and folders here. And there is a strange new file called trim.sh. I'm going to be using this bash script to implement fastp because I'll be working on multiple sequencing reads together. Yeah, I'll be working on multiple reads together. So what this script would do is I will open it using nano trim. Yeah. So what it does first, it calls bash. Okay. Some people ignore this, but I just like to use it. Then the next thing is to make a directory called QC reads. So you can already rename this to Q. You can rename it to whatever you like. Okay, it's okay. And then the samples. Remember, the samples have a prefix before them. Before you have this underscore R1 .fastq.gz, you have this prefix that is unique to the forward and reverse strands. In your case, maybe you downloaded it from the NCBI sequence read archives. You might have something like the SRR ID, and that makes them unique for the forward and reverse strand. So depending, you can always fix it. Then you have this, you have Baxter, Chara, and Drysdale. Then I now call a for loop to pick for each of the sample in samples. Okay, for each sample in samples, do fastp. Now it picks the forward using this, it picks the reverse using this, it picks the it outputs the forward here and outputs the reverse strand also here. And then it prints out an HTML report, which can also be subjected to multi-QC later on. So that's up to you. So one quick thing is that QC, so we did not specify, we specified this present working directory to actually use because we want our folders to be in the present working directory. So what I would do is to quit this and then move trim.sh. I'll move it into our raw reads folder. Yeah, sorry, I'm copying it rather, not moving. Then you open raw reads. Let's list it. So we have trim.sh, and then it can easily be implemented using bash, then trim.sh, and then, yep. Yeah, so it's quite fast because our samples are quite of the low size, but then it's done. You can list your files and folders. Then you have a new folder called QC reads. I can decide to rename it as move QC reads to trimmed reads. So this is better. And then if I list it again, it has changed to trimmed reads. Then I can try to open trimmed reads. And then let's see what's inside trimmed reads. So we have these, we have Isibari, we have Alsen, forward and reverse. So at this time they've been trimmed, and then you can decide to open the HTML report. So that's how to simply use fastp to quickly trim your quality, your reads. It trims the adapter off, it trims the low quality reads off, and it performs the duplication all at once. And automatically by itself, it identifies the right kind of adapters that were used for your experiments. So that makes life easy for you, because searching for adapter sequences can be a pain sometimes. So that it makes your work pretty fast and neat. Script I shared, I used here, you can automatically duplicate for your use case as well. The link to this script will be shared in the descriptions below. Thank you once again for listening, and move over to the next step in the pipeline.